Alright, let's start with the big question. What exactly are tectonic plates? Imagine the Earth's surface is like a giant jigsaw puzzle made up of massive slabs of rock. These pieces are called tectonic plates, and they float on top of the Earth's mantle, which is a hot, semi-liquid layer beneath the crust. These plates are constantly moving, slowly but with enormous force. There are about 7 major plates, like the Pacific Plate, North American Plate, and Eurasian Plate, as well as a bunch of smaller ones, and they're all interacting with each other. But here's the fascinating part. These plates are the reason why we have earthquakes, volcanic eruptions, mountain ranges, and even oceans. They shape everything around us. Now, tectonic plates don't just drift aimlessly. They move because of a process called mantle convection, where heat from deep within the Earth causes the semi-molten rock in the mantle to circulate, kind of like a lava lamp. As the mantle moves, it drags the plates along, but very slowly, only a few centimeters each year. But over millions of years, this adds up, which is why we can go from having a supercontinent like Pangaea millions of years ago to the continents we see today. So what happens when these plates interact? This is where things get exciting. There are 3 main types of boundaries where tectonic plates meet, and each one causes something different. Divergent boundaries. This is where plates are moving away from each other, and new crust is formed. A great example is the Mid-Atlantic Ridge, where the Eurasian and North American plates are pulling apart, creating new ocean floor between them. Convergent boundaries. This is when plates move toward each other, and one plate often gets pushed underneath the other in a process called subduction. This is how you get mountain ranges like the Himalayas, where the Indian plate is colliding with the Eurasian plate. And if an oceanic plate is involved, like the Pacific plate, it sinks beneath the continental plate, causing volcanic activity, like what we see in the Ring of Fire. Transform boundaries. Here, plates slide past each other horizontally, and this is where you get a lot of earthquakes. A well-known example is the San Andreas Fault in California, where the Pacific plate and the North American plate grind past each other. Now, you might be thinking, okay, tectonic plates move, but why does this matter to me? Well, tectonic plate movements have a huge impact on our lives. Earthquakes, for example, happen when plates get stuck as they try to move, building up pressure. When they finally release that pressure, the ground shakes, sometimes with devastating consequences. The same goes for volcanoes, which tend to form near subduction zones where one plate is diving under another, creating magma that erupts to the surface. And it's not just natural disasters. Tectonic plates also explain why we find fossils of ancient marine creatures high up in mountain ranges. Those mountains used to be at the bottom of the sea before tectonic forces pushed them up. Plus, plate tectonics are responsible for creating minerals and resources like oil, coal, and even diamonds, by influencing the pressure and heat conditions in Earth's crust over millions of years. Here's a fun fact. The Atlantic Ocean is actually getting wider every year as the plates on either side are slowly pulling apart, while the Pacific Ocean is shrinking. And in about 50 million years, Los Angeles might be sitting next to San Francisco as the Pacific Plate continues to slide north along the San Andreas Fault. And here's another cool one. Without tectonic plates, life as we know it might not exist. The movement of plates plays a big role in the carbon cycle, which helps regulate Earth's climate. This might have been key in creating the conditions that allowed life to evolve. So, whether you're living in an earthquake-prone area, hiking in the mountains, or just gazing at the ocean, tectonic plates are always in action beneath your feet. They're the invisible forces that sculpt our world and make it what it is today. If you found this breakdown of tectonic plates helpful, be sure to hit that like button and subscribe to Jersey Ore for more geology content. Drop a comment below if you've got questions or if there's another topic you'd like to learn about next. Thanks for watching, and stay curious, explorers.